Hello everyone, we are data miner team of 3 students presenting our final assignment on building Help Review customer support system. Myself, Rakhi Raji, will begin by explaining the thematic analysis we performed to identify the key topics from the customer feedback. Then next team member Shreya will walk you through the sentiment analysis and how it helped us understand customer emotions. Finally, Purna will present the QA system we developed to automatically respond to the common customer queries. Project overview. This project focuses on building customer support system using Help review data. The system performs thematic analysis, sentiment classification, and a question answering engine. Key techniques include NLP processing, LDA and NMF top modeling, TF-IDF logistic regression, SVM, and semantic search. Ethical considerations such as data privacy and bias mitigation are also integrated. Introduction. This project focuses on analyzing Help customer review from 2017 to 2022 using natural language techniques. Help is an American-based company that developed website for publishing the customer review about different businesses. The dataset contains thousands of real-world reviews which often are unstructured, noisy, and inconsistent, posing challenges in terms of test cleaning, sentiment ambiguity, and extracting meaningful insights. To address these challenges, the final phase of the project developed a comprehensive NLP-driven customer support system. This support system performs thematic analysis to identify key topics, sentiment analysis to understand customer opinion, and implement a question QA component to respond to frequently asked customer queries. Data collection and pre-processing. Data loading. The dataset from Help consists of customer reviews from 2017 to 2022 that contained around 38 lakh plus rows and 9 columns. Analyzing the entire dataset caused challenges, difficulty in memory loading and processing. Also, this large file took more loading time and increased RAM usage. So to reduce the processing time and to ensure representative subset of data, random sampling was performed on this Help dataset and sampled down to 1% for efficiency. Data cleaning. Columns like review ID, user ID, and date were dropped, which are not used for the analysis. Text pre-processing. The data pre-processing pipeline include remove special characters, numbers, and punctuation, convert text to lowercase, tokenize text into individual tokens, then and removed stop words. Feature creation has also been done, like clean test column was created to store the processed text and to use it for topic modeling, sentiment analysis, etc. Thematic analysis. Thematic analysis is a method in NLP which is used to identify and interpret patterns or themes within textual data. To uncover most prominent themes in Help customer review, we have used topic modeling techniques. Firstly, we have converted the cleaned reviews into a document term matrix, and this numerically present how often word appears in each document. To uncover the latent topics, we have used both LDA and NMF topic modeling methods. LDA was applied to discover hidden topics in customer reviews, and these topics offer business insight into the major themes customer cares about. These are the topics, topic 1 to topic 5, and topic 1 mostly captured like order, food, chicken, good places, and topic 2 was mostly related to service quality and customer experience, and topic 3 focuses on ordering experience, and topic 4 centered on customer satisfaction. Topic 5 was mainly related to food quality. Next is NMF topic modeling. NMF topic modeling is also applied to discover the hidden themes in the customer review by identifying group of words that appear together. This helps the business to turn large unstructured reviews to meaningful topics. And these are the topic 1 to topic 4. Topic 1, frequently comment on taste and quality of food item. Topic 2, customer expression to poor service experience, issue inaccuracy, and topic 3 mainly about long wait time and slow service at restaurants. Topic 4 was mainly for the positive reviews and praise the staff and great services. The thematic insights from LDA and NMF model help and business to understand what aspects of customer experience stands out the most. Ngram analysis. Uh, for further understanding of the common expression in the reviews, we have also performed the Ngram analysis, which helps to identify and frequently used phrases. Common bigrams like customer service, highly recommended. Um, uh, these uh, these bigrams helps key occurring themes in customer feedback. Common trigrams such as would highly recommend, great customer service, and definitely come back, reveal strong emotional and loyalty driven sentiments. This analysis shows what customer talk mostly in reviews, and which will help the business with actionable phrases to monitor or promote. A comparison, performance comparison was also done where LDA versus NMF, and we have compared the coherence performance of LDA and NMF in capturing the topics by calculating its coherence score and its execution time. And based on this analysis, NMF outperformed LDA with a coherence score of 0.7675 and run much faster compared to LDA. Based on this analysis, it is clear that NMF produced more meaningful topics which with more efficiency for this dataset. Word cloud for topics. We have also generated word clouds that provide quick overall visualized summary of the top words in each topic for LD and NMF model, and these are the diagrams. To sum up, thematic analysis help business understand what customer talk about the most in their reviews. By finding common topics like a long wait time, great service, business can see what they are doing well and what they need to be fixed. This will make it easier to focus on the area that matter most to the customers and will help to improve its overall experience. This is about my topic. Over to you, Shreya, for sentiment analysis.
Moving ahead, let's talk about sentiment analysis, a key part of our project. The goal here was to classify reviews into positive, neutral, or negative categories based on the content and the tone of the text. We started with a supervised learning approach where Yelp reviews were first labeled based on their star ratings. For instance, 4 to 5 stars were marked as a positive, 3 as neutral, and 1 to 2 as negative. Then we used TF-IDF vectorization to convert this text into numerical features that machine learning models can understand. We tried two classification models, logistic regression and support vector machines, that is SVM. Both gave us strong performance with an overall accuracy around 88%. In both models, the positive class was the easiest to classify. You can see high precision and recall above 90%. However, the neutral class was significantly harder to classify. Recall dropped to just 18 to 19% and F1 scores were low. This tells us that neutral reviews often have ambiguous or mixed language, making it tough even for machine to decide how they feel. To cross-validate our findings, we compared this with a rule-based approach using the VATER sentiment analyzer, which is specially tuned for social media and review texts. VATER calculates a sentiment score for each review using predefined lexical rules. We tested its output against our star-based labels. As shown in this sample, A VADR correctly labeled most reviews the same way as the star-based system. For example, 4 stars and 5-star review were tagged positive, aligning well. However, one interesting case was review ID 3599297, a 2-star review that VADR still marked as positive. This shown this shows a potential limitation of rule-based methods. They don't always catch sarcasm or subtle criticism, which human and sometimes ML models can learn to detect better with training. So, overall, our findings validate that both supervised and rule-based sentiment analysis methods can be quite reliable, but each has strength and weakness. Supervised models offer higher customization and learning ability, while VADR is fast and interpretable out of the box. This combination of techniques gave us a well-rounded view of customers feel, which is critical for any business aiming to improve its services based on real feedback. This slide presents the distribution of sentiments across customer trip reviews visualized through a bar chart. As we can see, the majority of feedback falls into the positive sentiment category, represented by the green bar on the left. This indicates a generally high level of customer satisfaction, with many users expressing favorable experiences. In the middle, we can see a significant portion of reviews marked as negative, shown in gray. These highlight areas where customers encountered issues and they provide critical insight for improvement. On the right, the neutral sentiment bar, shown in orange, represents reviews that were either mixed or objective, without strong positive or negative expressions. Overall, the distribution helps us understand the emotional tone of customer feedback at a glance and can guide business in prioritizing improvements and maintaining strengths.
So let's begin with a look at the sample QA system results. The system was designed to evaluate different aspects of customer experience by analyzing textual feedback. Under delivery experience, the system found a mix of reviews, with some customers explained about the delays, others praised the punctuality of the service. In terms of customer service, complaints were effectively identified using high semantic similarity scores, highlighting the model's ability to detect recurring issues even when phrased differently. Cleanliness was generally well received. The most customers provide positive feedback. This indicates a strong customer satisfaction in that category. For food quality, the review varied more. Some praised the meals while others occasionally flagged issues. The system captured this variability effectively. The QA system leveraged schematic analysis to exactly meaning beyond keywords, providing a richer understanding of customer sentiments. Next, let's discuss the ethical assessment of our system. First and foremost is privacy protection. We ensured that all personally identifiable information was removed from the dataset to maintain customer confidentiality. Bias mitigation was a key consideration. The system was assessed to ensure that diverse voices were accurately represented, and this sentimental analysis was not skewed against any demographic. Under ethical guidelines, we recommended regular audits, model retraining, and continuous monitoring to detect and address any emerging bias or ethical concern. Looking ahead to future steps, we plan to conduct fairness audits and ethical performance evaluations where this model is updated. This will help us maintain accountability and improve over time. In conclusion, our system successfully demonstrated an end-to-end pipeline from raw text cleaning all the way to insightful customer feedback analysis. We found that both thematic analysis and sentimental classification were crucial. They allowed us to effectively extract meaningful and actionable insights from customer comments. Finally, this project illustrates the sentimental QA can be a valuable tool for real-world applications, particularly in customer support and business intelligence. It shows a promise in helping business better understanding and respond to customer needs. For those interested in seeking this work in action, you can find this video presentation. Thank you for your attention.